Hi guys, welcome back. This is Professor Hank, and in this video, I'm going to talk to you about some advice on learning how to program for your beginning computer science classes. So, I get this question all the time. Somebody maybe doesn't do as well on a particular test as they would have liked. They didn't do as well on a homework assignment. They're halfway through. They're kind of struggling, and they ask me, "Well, what can I do different? What should I be doing? How can I?" Get better. What do I need to do, right? And basically, what it boils down to is you have to program. You learn by doing, and so I tell my students on day one when we go through the syllabus, that document that nobody ever wants to pay attention to, and you zone out, whatnot in class because it's the same old boring crap that you've heard 3 times that day already or whatever. But for my students, I tell them as part of going over the syllabus, as I warn them, I say, I'm not going to give you enough homework for you to be successful. Period. Right? If I could get away with it, if I had the bandwidth to assign 100 programming assignments a week, I'd do it. Right? I can't because the students would kill me and I'd kill myself trying to grade all of that stuff. But if I could, I absolutely would. You can't program enough, right? So that's probably the number one thing. Okay. Another thing is read the damn textbook. I can't tell you how many times people try to take a class, they don't want to read the textbook, they don't know what they're doing. They try to Google something at the last second, it doesn't work, they can't figure out. Email me or stop by my office hours and say, I can't figure out what's going on. And so then I start talking to them about stuff we've covered in the class and in the textbook. And you just get this blank look, this blank stare back at you as they're blinking, going, what are you talking about? What's a method? I don't understand. Did you read the damn book? Read the textbook. Read the textbook, right? Now, reading the textbook's generally not enough for everybody, right? But it's the starting point. Okay, read the textbook, watch the lectures, come to lecture, take notes, right? Don't just sit in a room and be a passive participant. Because, nobody ever went to, say, a calculus class, right? And just listen to the professor talk for an hour and 15 minutes. You're like, yeah, okay. Got it. And then they learn to calculus. That's not how it works. That's not how it works at all. It's a labor intensive process, and so is learning to program. You got to read that textbook. You got to write code, right? So I tell students, go over the chapters with a fine tooth comb, right? Now that we're in COVID land and you've got videos of lectures, rewatch the lectures 27 times. Man, I wish I had that technology when I was a student, because if there was something I missed in a lecture, you can't really rewind and go back, in person, right? But in COVID land, when you got lectures that are pretty much recorded, right? At least I record all my lectures. You can go back and you can watch that 3, 4, 8, 12, 17 times. And if I'm doing a class and I say, watch this lecture, read this chapter, then watch that lecture and read this chapter, right? So many times people, they don't do well in that. They're just like, I can't understand why I missed anything. I can't understand why you're not doing well in this. Maybe it's because you didn't do the work, right? It's not because you're not smart enough. It's not because you can't do it. It's just because you didn't do it. So read that textbook. I also tell them, the example code isn't there for you just mindlessly copy and hope that it works somehow, right? The starting point isn't copy code and then try to fool with it until it works and turn that in for a homework assignment. The starting point is reading the text and understand what the text is trying to say, right? And that code is there to illustrate what the text is trying to say. Or in lectures in class, if I'm writing code on the board, or if I'm referring to some code on a slide, or if I'm typing something up, that's there to illustrate what I've been talking about the past 20 minutes, right? You don't just zone out and then as soon as you hear that typing on the keyboard, start, tuning in at that point. Because you don't know what the code's actually doing. You don't understand what's being demonstrated. The whys are far more important than the hows. That's another thing that I tell students is you have to understand why this code is here, why it's doing what it's doing. Trace through the code, right? Learn that skill. Dear God, learn that skill. Trace through the code, understand what each line's doing one by one. Don't just guess, right? I hate that question. People send me their code and they're like, does this look right? I'll be like, I don't know, does it? You tell me. You're the one writing the program. Why'd you write it? What's it supposed to do? Why is it there? Why did you make that loop? Why did you make that define that variable as an integer instead of a float? Why? Well, I don't know. Well, then go back and reread that section of the textbook or rewatch that lecture, that part to answer why, right? So that way you know why. So that way you don't say, I don't know, right? This isn't guessing. You're trying to master. You're trying to learn the material. Learn it. So I also encourage them, when you're going through the sample code, you're reading that section, or you're rewatching that part of the video, type the code out yourself, right? Type it out one line at a time, see how the program changes as each line is being compiled and ran. Okay, do that. And in the ends of the chapters, for the textbook that we have, which is an excellent textbook, you probably have all used it if you're a computer science student. I mean, it's the textbook for C++ and Java now and Python and other languages. The textbook by Tony Gaddis, that author, he does a really great job. I wish that that was the textbook that I had access to when I was a student. But in the ends of those chapters in those textbooks, there's all kinds of programming assignments in there. And, there's usually 10, 15, 20 programming assignments. Do them. Do all of them. Because your instructor and me, I'm specifically speaking for myself, I'm not going to be able to give you enough homework for you to be successful. You're not going to learn how to program 10 minutes before an assignment is due, just copying and pasting some sample code and then making a couple quick edits and then submitting it and hoping for the best. You have to understand what's going on and why the code does what it does and why you're typing it out, right? You're typing your code out, you're writing a program to solve some kind of problem, to fulfill some kind of requirements. And so, you have to understand why you would choose an integer instead of a float. You have to understand why the return type is by reference, right? You have to understand why you have 3 parameters instead of 2 or whatever, right? There's reasons. You have to understand those reasons. You don't just guess. You don't just say, oh, I have to make my program's output look like that. And then, write a program completely ignoring whatever the requirements were. And then turn it in and then you get, crappy score. And you're like, I don't understand. My output looks just like that. Yeah, but I asked you to write 3 functions. I asked you to make sure that none of the functions interact with the user in any way. I asked you all these different things. I wanted you to write the code in a certain way, right? Because you don't get to choose, unless it's your own project. You don't necessarily get to choose how you're going to write an application, especially if you're working for somebody else, right? I mean, if you are working for someone else, you're not going to get to just make stuff up. And if you're trying to learn a particular feature of the language, and that's what we covered in that chapter, I'm going to ask you to write your code in a certain way so that way you can get reinforced with that feature, or so that way your understanding of that feature can get reinforced. You don't just get to, ignore everything that we just talked about and just make it up. For example, we just had a test at the junior college that I work at, and I had a programming question where I said, write a function that does something with a binary file, that writes some data to a binary file. Multiple students are like, nah, not going to do that. I'm going to write it to a text file instead. And like it gets the integers get stored in the file, so that's good enough, right? No, it's not good enough. You got no points for that. That doesn't demonstrate that you understand how a binary file works. Okay, binary file, text file, oh, it's all just files. No, it's not. They're two completely different things. And there's different reasons to use either one of them. All right. And so you have to understand what those reasons are. So that way, when you're trying to solve a problem, you can pick the right tool for the job. Okay. But anyway, so I mean, these are the kinds of things that I did when I was a student, right? I would go through, read the material. Sometimes I'd have to reread it like 20 times because halfway through a paragraph, you're sitting there and your brain starts to wander, and you're like, damn it, what was I thinking again? What was I reading again? Then you got to go back and you got to start over. It's frustrating. It's annoying. It sucks. But that information in the text is the foundation, right? And so then I would go through and do the same things. I would type up some of the sample codes, see how it works, make sure I understood that, and then I do extra programming assignments, right? I would write programs, and then I would write programs on my own for fun just to see how it worked. A good thing you can do, even if you know how to program, right? I mean, for me, I have the basics of knowing how to program now pretty good. For me, when I try to learn a new programming language, what I'll do is I'll say, okay, well, how does a loop work? Right? How do I get input from the user? Right? How do I display output to the user? Right? I don't try to do all those things all at once. I'll say, okay, let me make sure. Let's isolate a loop. Let's see how a loop works. Okay, cool. Now I know how that repetition structure works. Let's see how I can make a decision in this language. Write a stupid little throwaway program that just has an if statement in it, and then see how that works. Write a hello world program just to see how you display something on the screen. And so you're learning these little tools, these individual pieces, one bit at a time. And once you understand how to use them by themselves, then you can plug them into more sophisticated, more complicated programs, right? If you can't write a program to do something silly or to just to display output on the screen just by itself, you're not going to be able to write a program that is integrating all of these tools, right? So, if you can use the tool in isolation first, that's the first thing you have to do. So then once you can use the tool in isolation, then you can combine it with other tools to make something a lot more sophisticated, right? So to summarize, when you're trying to learn what you should do, read the textbook, number one. Number two, pay attention in lecture. Watch the lecture videos. Rewatch them if you have to. Reread the textbook multiple times. Trace through the sample code examples and realize that you don't start with the sample code. You start with the reading of the textbook. Right? You read the textbook so that way you understand what's being discussed, and then you look at the code and see how that's a manifestation of the concepts that are being talked about. Write code, write your own programs, right? And write your own programs. Do extra assignments at the ends of the chapters if they're given to you in whatever textbook you're using. Understand. Ask why. Why does this code do this? Why would I choose a for loop instead of a while loop? Why would I make this const as opposed to not const, right? Why would I return by reference instead of return by value, I guess you could say? Should my function display anything ever? How do I display something? So why would I use cin versus getLine, right? What happens? I mean, the whys are really, really, really important. So anyway, that's just some things I was thinking about because, I get this question a lot. How can I get better? How can I get better? How can I get better? Those are some things you can do. Those are some tools you can put in your toolbox. But also, repetition breeds retention. What does that mean? Practice makes perfect, right? There's no shortcuts, right? You got to put the work in. You're not gonna, like I said, you're not gonna be able to just program 5 minutes a week, and then at the end of the semester go, oh yeah, I learned C++, or I learned Python. I spent 20 minutes the entire semester writing code. Nope. You have to put extra work in. Right? So just like learning a human language, right? I'm trying to learn Spanish, and now I'm playing around with Portuguese a little bit. And I try to spend, oh, geez, half hour, 40 minutes a day learning the language or looking at the language, listening to videos and, on my Duolingo, reading books and all that kind of stuff. You have to do a little bit every day before you finally get a grasp on what's going on. It's not something that you're just going to be able to do in 5 minutes a day and then forget about it. You have to constantly work at it. So anyway, just something I was thinking about, and just something I would pass on. Of course, everybody learns differently, but that's what worked for me. That's what worked for me. Read the textbook, use that to actually understand what the sample code's doing and why. Trace through the sample code. Hand tracing is just amazing for that. Practice, 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 and do lots and lots of programs. Not just the homework. The homework is the absolute bare minimum. And like I said with my students, I tell them it's not enough. Right? I'm not going to give you enough homework to be successful. So, just something to think about. Is there anything else I want to tell you about? No, I think that's about it. I mean, the people who don't succeed, I mean, generally speaking, they just give up too soon. I think for most people, they just give up too soon. So you just got to keep working at it, understanding the whys, and not the hows. Okay. All right. Anyway, that's all. Thanks for watching. Hopefully you're keeping yourself safe in COVID land. Stay home. If you have to go out, wear a mask, wash your hands, don't touch your face. We're this close to a vaccine, 6 months away, right? Don't die a month before the cure comes out. Don't do it. All right. Take care of yourselves. We'll see you.